So this is derivative as a rate measure. It's an application of derivative topic, and I'm Suman Matthews. You will learn how derivative is used as a rate of change. Problems are illustrated. So dy by dx represents the rate of change of y with respect to x. If y increases, dy by dx is greater than 0. If y decreases, dy by dx is less than 0. So this is what you need to remember. Now, if the radius of a circle increases at the rate of 3 centimeter per second, at what rate is its area increasing when its radius is 10 centimeters? Area is pi r squared. So what is dA by dt? Pi into 2r dr by dt. Now radius is increasing at the rate of 3 centimeter per second. So dr by dt will be 3. R is 10. So it will be 2 pi into 10 into 3, that is 60 pi centimeters squared per second. Next question. A spherical balloon has a variable radius. Find the rate at which the volume is increasing with respect to the radius when the radius is 10 centimeters. Now volume is 4 by 3 pi r cubed. So what is dV by dr? 4 by 3 pi into 3r squared. Now when r is 10, it becomes 4 by 3 pi into 3 into 100, that is 400 pi centimeter cube per centimeter. A cylindrical tank of radius 10 centimeter is being filled with wheat at the rate of 314 cubic meter per hour. Find the rate at which the depth of the wheat is increasing. Pi is 3.14. You have to take pi as 3.14. Now what is the volume of a cylinder? Pi r squared h. So radius is r, so it will be pi 100 into h. So dV by dt will be 100 pi dh by dt, and the volume is being filled at the rate of 314 cubic meter per hour. So 314 equal to 100 into 3.14 dh by dt. So dh by dt will be 1 meter per hour. The next problem. The total revenue received from the sale of x units of a product is given by Rx equal to 3x squared plus 36x plus 5. Find the marginal revenue when x equal to 5. Now marginal revenue is derivative of revenue, that is derivative of 3x squared plus 36x plus 5, which is 6x plus 36. So marginal revenue when x equal to 5 will be 30 plus 36, that is 66. Coming to the next problem, a stone is dropped into a quiet wave and waves move in circles at a speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? So we have circles. The wave is forming circles in the water. Area of a circle is pi r squared. What is dA by dt? 2 pi r dr by dt. So put dr by dt as 5 and r as 8. So you get 16 pi into 5, that is 80 pi centimeter squared per second. Coming to the next problem, the length x of a rectangle is decreasing at the rate of 5 centimeter per minute and the width y is increasing at the rate of 4 centimeter per minute. If x is 8 and y is 6, find the rate of change in the perimeter and area. Now we have the length and breadth. What is the formula for perimeter? 2x plus 2y. So dp by dt will be 2 dx by dt plus 2 dy by dt. Substitute. You are given that the length is decreasing, so it will be 2 into minus 5. The breadth is increasing, so it will be 2 into 4, that is minus 2 centimeter per minute. Now area is xy. So dA by dt will be x dy by dt plus y dx by dt. Substitute for dy by dt and dx by dt. So you get 2 centimeters squared per minute. You also substitute the value of x and y. X is 8 and y is 6. Coming to the next question, a particle moves along a curve y equal to 2 by 3x cubed plus 1. Find the points on the curve at which the y coordinate is changing twice as fast as the x coordinate. Now y is 2 by 3x cubed plus 1. So what is dy by dt? 2 by 3 into 3x squared dx by dt. The y coordinate is changing twice as fast as the x coordinate. So what is y? It is 2x. So dy by dt is 2 dx by dt. Substitute here. So I get 2 dx by dt is 2x squared dx by dt. Dx by dt cancels. You get x squared equal to 1. That means x equal to plus or minus 1. And what is y? You are given that the curve is y equal to 2 by 3 x cube plus 1. Substitute these values of x. So y is minus 2 by 3 plus 1 if x is plus minus 1, and if x is 1, y is 2 by 3 plus 1. So your points are 1 5 by 3 and minus 1 1 by 3. Coming to the next question. A girl of height 1.6 meters walks at the rate of 50 meter per minute away from a lamp which is 4 meter above the ground. How fast is the girl's shadow lengthening? So we have drawn the figure here. The girl is here, height 1.6 centimeters. So we have two triangles here, and using similarity, I can say 4 by x plus y is 1.6 by y. So cross multiplying, you get 4y is 1.6x plus 1.6y. 2.4 is 1.6x or y equal to 2 by 3x. So what is dy by dt? 2 by 3 dx by dt, and what is dx by dt? Dx by dt is 50. So it's 2 by 3 into 50, that is 100 by 3, which is 33 1 by 3 meter per minute. Coming to the next question. A kite is 120 meter high and 130 meter of string is out. If the kite is moving horizontally at the rate of 5.2 meter per second, find the rate at which the string is being pulled. So this is the kite, it is being pulled. Now we know that x squared is 130 squared minus 120 squared, so x is 50. And now you have to find L, because if it is being pulled, you have to find the rate, you have to find L here. So going back to the question, you need to find the rate at which the string is being pulled. So I need to find dl by dt. Now L squared will be x squared plus 120 squared. That is 2L dl by dt will be 2x dx by dt. Put x as 50, L as 130 and dx by dt is 5.2. Why is dx by dt 5.2? Because the kite is moving horizontally at the rate of 5.2 meter per second. So when I substitute, I get dl by dt is 2 meter per second. Coming to the next question. A circular cone with semi-vertical angle 45 degrees is fixed with its axis vertical and vertex down. Water is poured into the cone at a rate of 2 centimeter cube per second. Find the rate at which the depth of the water is increasing when the depth is 4 centimeters. So volume is 1 by 3 pi r squared into h. Simplifying, you get 1 by 3 pi if you put r equal to h here, because the angle is 45 degrees, so r equal to h, so you get 1 by 3 pi h cubed. So what is dv by dt? 1 by 3 pi 3h squared dh by dt. Now dv by dt is 2, because you are given that the water is poured at a rate of 2 centimeter cube per second. And this is pi h squared, h is 4. You have to find dh by dt. So dh by dt will be 1 by 8 pi centimeter per second. So this is applications of derivatives, derivative as a rate of change. So take a pen and paper and practice every line along with me, and see you in my next session. Thank you.